All right, awesome. So in the last video, we talked about Boyle's law, and we talked about the relationship between pressure and volume and how it exhibits a inverse relationship. But in this video, we're going to be talking about Charles' law and how the relationship between temperature and volume in an ideal gaseous system is not inverse, but it's actually a direct relationship. So what does that mean? It means that if we're increasing the temperature of a system, the volume's also going to increase and vice versa. So one goes up and the other will go up. One goes down, the other will go down. So we have a general equation for our Charles law. So we're going to go V1 over T1 set equal to V2 over T2. And just like Boyle's law, we can isolate for any of these variables and solve for one of these variables as long as we have enough of the other pieces of the puzzle, metaphorically speaking. So in general, you're going to want to convert between Celsius and Kelvin. All you do is you add 273.15 to the Celsius. Just keep in mind you want to honor the sig fig rules for addition and subtraction, right? So with this in mind, let's do a practice problem. So we say a gas occupies 221 centimeters cubed at a temperature of 0 degrees Celsius and a pressure of 760 millimeters mercury. What will be the volume at 100 degrees Celsius? Okay, so first thing that sticks out to me is the 221 centimeters cubed. So don't let this scare you. Centimeters cubed is synonymous with milliliters. So 221 centimeters cubed means 221 milliliters. Just another way to write it. So let's see. It looks like our 221 centimeters cubed slash milliliters is going to be our V1. Our T1 is going to be this 0 degrees Celsius, which we're going to later convert to Kelvin. Our pressure is 760 millimeters Hg, and we are given a volume of 100 degrees Celsius. Okay, so it's important to note that 760 mmHg is equal to 1 atm, so that's STP. So that's not going to mess anything up, right? And we're given a looks like a V2, or excuse me, a T2. So we're solving for a V2. So we have our T1, excuse me, our V1, and we are given a T2, right? So how about we pause the video right now and then work it out on your own and then come back to it. All right. So hopefully you've at least tried. So the first thing we're going to do is do a quick conversion from Celsius to Kelvin. So all we're doing is adding that 273.15. We're going to be isolating for that VT in our Charles law equation. So we're going to rearrange using algebra. I call it the crisscross method. But basically, you're going to end up with VT. You're going to find the product of 221 milliliters and 373 Kelvin. Then you're going to divide that product by 273 Kelvin, right? And then our V2 is going to be 302 milliliters. Or you can also write it as 302 centimeters cubed. So the big question is, does this correspond with our qualitative understanding of Charles' law? Yes, it should. But why is that? So let's look at our V1 and our V2. So our V1 is 221 milliliters, and our V2 is 302 milliliters. So it's going up. So if we're trying to confirm our Charles law hypothesis, we're going to expect the temperature to also go up. So our initial temperature is 0 degrees Celsius, so that's 273 Kelvin. And our final temperature is going to be 100 degrees Celsius or 373 Kelvin. So it's going up as well. So this confirms our hypothesis and also confirms our quantitative answer. Okay, well, I hope you guys enjoyed the video and I hope it helped.